So to find the exact difference between the volume of a sphere with a radius of 8 feet and another sphere with a radius of 10 feet, you're going to find the volume of each of those spheres. So, volume of a sphere is 4/3 pi r cubed. So for the 8-foot radius, we do 4/3 pi 8 cubed. So 8 to the third power is 512 times 4, you get 2,048. And then if the radius was 10 feet, you do the exact same formula, 4/3 pi times the radius cubed. Now I am not multiplying in 3.14, I'm just keeping the symbol right there, because it said exact. Whenever it says exact, you're keeping the symbol pi rather than multiplying 3.14. So the exact difference between those two, they both have the pi, so that's not part of the difference. They both have the 3 in the denominator, that's actually not part of the difference. The only difference is whatever 4,000 minus 2,048 is. 1952 pi over 3. That is the exact difference. When you subtract those, they've got the pi in common, they have the denominator common, so you just subtract the numerators. 1952 pi over 3. Which is approximately 2,043 cubic feet. So since it said exact, we don't divide the 3, we don't use 3.14, we just keep it all there as a fraction. So then we've got another part to this. Does a sphere with a diameter of 15 feet, that means a radius of 7.5. And another sphere with a diameter of 16 feet, that means a radius of 8 feet. Is that a larger difference, greater difference, or a smaller difference, or less of a difference? So we do the exact same setup. 4/3 pi r cubed. Going to keep the 3 in the denominator. It's weird to have a decimal point in the numerator, but we'll leave it for right now. And we do the same thing with the radius of 8. We already worked that out a little while ago. Right there, the 2048 pi. So is that more or less of a difference? Well, that's only a difference of 400 and something in the numerator, which is much less. Much less. So looking at all the cross sections of a cone, if you go parallel to the base, you get a circle. If you go diagonally through the sides, you get an ellipse. If you go through the side, down to the base, through the base, you get a parabola. Through the side, down to the base, that's also a parabola. And this last one's pretty difficult to see, but it says perpendicular to the base, and we're coming straight down through it. So perpendicular to the base, straight down through it. I'll highlight it. You get an isosceles triangle. The Millers are resurfacing their pool deck. There's a picture of their pool. If they want a 2-yard width all the way around the pool, estimate what the square footage would be for the pool deck. So we're going to approximate it as a rectangle. It's almost a rectangle. It's pretty close to it. Let's make the pool be a rectangle. And then around that, we're going to have 2 yards all the way around. So we're going to add 2 more yards, which is 2 yards. A yard is 3 feet. So that's 6 feet. All the way around. We're going to go out 6 more feet to the left, 6 more feet to the right, 6 more feet on top, 6 more feet on the bottom. So our small rectangle is 15 feet by 34 feet. And then when we add 6 feet all the way around it, we add 6 feet on the right and the left. So we're adding 12 feet to the 34 feet. It's 46 feet. And then 12 feet also because we're adding 6 to the top and 6 down below. So that's 12 plus 15 is 27 feet. So what would be the estimate for the square footage for the pool deck? We would do the large area minus the small area. So we're going to do the 27 times 46 minus the 15 by 34. So 27 times 46 is 1,242. 15 times 34 is 510. Subtract. And that means we have a 732 square feet of concrete going around the pool. Because we found all the whole area minus the area of the water. A circular island has a radius of 16 miles and a population of 34,000. What is the best estimate of how many people per square mile own a bicycle if it said that 22,000 people own a bicycle and 10,000 people own a car? So the only thing we want to know is how many people per square mile own a bicycle. So we want to know how many bicycle owners per square mile. So that means we're going to take the 22,000 bicycle owners divided by however many square miles this island is, which is the area of the island, and it says that the radius of the island is 16 miles. Area is pi r squared, because it's a circle. So 16 squared is 256, times pi is about 803.8. And then when we divide you get about 27.4. And then our units for that, we already wrote right here, 27.4 bicycle owners per square mile. So here we're trying to find the area of the sidewalk. We want to know how many square meters of cement for the area of the sidewalk. Now, to do that, we don't care about the diameter, we care about the radius. So if the diameter is 15, that means the radius is 7.5. All the way from the middle to the side, the outside. But we're not paving all of this area in here. It does not get paved, so we need to subtract that circle. So we're going to do the area of the big circle minus the small circle. So for the big circle, we have a radius of 7.5. So the big circle has an area of pi r squared, 7.5 squared. The small circle is less than 7.5 because the concrete, it says, is 1.25 meters. So if you subtract so the small radius then is 6.25, so that's pi times radius squared. And then this is not a full circle, it's only half of a circle, so once we're all done with that, we only want half of this final answer here. Because it's half of a circle, they're both half circles. So 7.5 squared times pi is about 176.6. 6.25 squared times pi is about 122. Not yet. Did not divide by 2 yet. 0.656, so we'll say 7. I have not done anything with the 1/2, so that's still there. So we're going to subtract and then divide by 2. So it's like 26.95. We'll just round that to 27. Square meters. So here we've got a bowl with a 6-inch diameter at its opening and a 4-inch diameter at its base, and the height is 3 inches. So if we had a cylinder that was full of water to its max, would it overflow or fit inside? So if it overflows, that means it's got a larger volume than the bowl. If it fits inside, it has a smaller volume. So if the diameter were 6 inches and the height were 3 inches. So since the bowl gets smaller as it goes down towards the bottom, and the cylinder has the large diameter, this would overflow. The cylinder has too much water in it. Would a cylinder with a 4-inch diameter, so that's the diameter of the bottom of the bowl, the skinnier diameter, and a height of 3 inches. So the same height as the bowl, but a smaller diameter, the diameter of the bottom, that would fit. and then a half spherical container. Now, since the bowl probably looks a little bit like this, and the cylinder is going to be more curved, it would fit. The sphere would be more curved than the bowl, so it would fit. Because the diameter is 6, which means the radius is 3, which fits within the height of the bowl also.